Welcome, Ichak Solution. This is inequalities. So in this lesson, we are going to be solving inequalities using graphical method here. So let's have here solve the inequality modulus of 2x minus 3 is greater than 6 minus x here. So to solve graphically here, so we need to consider the two graphs that we have. So the first graph that we have on the left hand side is the graph of y is equals to 2x modulus of 2x minus 3, and the other one on the other side is y is equals to 6 minus x here. Alright, so we need to draw these graphs on the same Cartesian plane and see where the graph of on the left hand side will be greater the graph on the right hand side here. Alright, so we are going to consider y is equals to modulus of 2x minus 3. So from there we can derive a straight line here, then we later on apply the modulus. So let's consider the graph of y equals to 2x minus 3 here. So we are going to say to draw a straight line here, we just find the intercept. So first we find the where the intercept when x equals to 0 and y equals to 0. So when x equals to 0, you see y equals to minus 3. Then when y equals to 0, you can see the graph cuts at x is equals to 2 over 3 by solving here. Alright, so now let's go on the Cartesian here. We are going to go on the Cartesian. Alright, so we are going to plot our points y equals to minus 3 and x is equals to 2 over 3 here. So these are the points here. Alright, so make sure you are plotting your points in a proportional scale so that this will improve our accuracy and also help us to come up with something which is very clear here. So this is now the line of y is equals to 2x minus 3. So you can see now the lower part here of the graph here, which is below the x-axis here. I put a dotted line. Why? Because we need to apply the modulus here. So the modulus means the negative part here is going to go to the positive, part here is going to be reflected to the positive part. So that's why I put a dotted line here. So minus 3 here will go to 3 here under the modulus here, because this negative 3 becomes 3 here. Alright, so now we are going to draw the graph of the reflection of this below the x-axis to the above y x-axis here. So this one becomes y is equals to negative open brackets 2x minus 3 here. So the moment when you reflect the graph from within the x-axis here, you just multiply with a negative to the graph here. So it's y is equals to negative 2x minus 3 here under the brackets here. Alright, so this is the graph that we have. Alright, so the next graph that we now have here is the graph of y equals to 6 minus x here. So we also find the intercept. It's a straight line. So when x equals to 0, you can see y is equals to 6. Put x equals to 0 here and get y equals to 6. Then when y equals to 0, also get x is equals to 6 here. We put 0 and get x is equals to 6. So now we plot on the Cartesian plane here. You can see there's 6 and 6 here. Then we draw our line here. So this is the line that we have, and we label it is y is equals to 6 minus x here. Alright, so you can see this graph is intersecting at 2 points. We have this point and these points here. So these are the critical points that we need to identify. So we can label them A and B here. Alright, so now the next thing now is to find the points, the x coordinates of A and the x coordinates of what? Of B here. Alright, so to find the x coordinates of A, you can see this is the point here. So to find the x coordinates of A, we are going to take the graph of y is equals to 6 minus x, this one, and take the graph of y is equals to minus open brackets 2 minus x close bracket minus 3 close bracket here. So we are solving for the x coordinates of A. So 6 minus x is equals to minus open brackets 2x minus 3 here. So we get x is equals to minus 3. So the x coordinate at A is minus what? Minus 3. All right, then we go for the x coordinates of b. So to find the x coordinate of b, you can see we are intersecting this point. So we are taking the line of y is equals to 2x minus 3, and the line of y is equals to 6 minus x here. So 6 minus x is equals to 2x minus 3 here. Then we solve simultaneously. We solve here, so we are going to have x is equals to 3. So the x coordinate here is x is equals to what? Is equals to 3 here. All right. So now we need to solve for the region. So the region that we want, we need a region where the graph of y is equals to modulus of 2x minus 3 is above the graph of y is equals to 6 minus x here, because we are saying on the inequality modulus of 2x minus 3 is greater than 6 minus x here. So we need a region where this graph is now above this graph here. So if you look closely here, you can see from this point going to this side here, this graph of modulus here, you see this blue line here that we have, is now above this red line. So starting from this point going to the left hand side here, you can see the graph is now above. All right, then if you take from this point here again, you can see the graph of modulus here, of modulus of 2x minus 3 is now above the graph of this one here. So this is the other region that we need here. So now our solution will be x less than minus 3. So if you take from this part going to the other side, and also union x greater than 3 here, if you take from this point going to the right hand side, that will be your solution here. All right, so let's go to the next example here. All right, solve the inequality modulus of 2x minus 3 less than modulus of x minus 5 here. All right, so you can see now we have modulus on both sides here. So let's just consider here. So we are first going to consider the graph of y is equals to modulus of 2x minus 3 here. So this is a straight line here, so y equals to 2x minus 3. So when x equals to 0, you see y is equals to minus 3. Then when y equals to 0, x is equals to 2 over 3 here. All right, so we just go on the Cartesian plane here. Then we plot our points, so minus 3 and 2 over 3. Then the next thing, we draw our line here and label it. Then the next thing, now we are reflecting the negative side here to the positive. So negative 3 become positive here since it's under modulus. So this is now 3 here. So the new graph that was reflected to the positive side here is now y is equals to minus open brackets 2x minus 3 here. So the combined graph here, that will be the graph of modulus of 2x minus 3 here. All right, so now we need to draw another graph here. So the graph that we need is the graph of y is equals to modulus of x minus 5 here. So this is also a straight line, so we can consider a straight line here. So y is equals to x minus 5. When x is equals to 0, you can see y equals to minus 5. Then when y is equals to 0, we have x is equals to 5 here. So we are going to plot here on the Cartesian. So this is minus 5 and 5 here. So now the lower part here, which is below the x-axis, we are just going to put a dotted line because we need to reflect it on the positive side, since we are operating with the modulus here. Right, so minus 5 becomes positive 5 here, so it's positive 5. Then we draw the graph here on the positive side here. All right, so now we are interested in the critical points. So our critical points here are going to be at this point. So this one, the reflected part, remember, it's now a negative open brackets x minus 5 here. So now our critical points, we have this critical point and also this critical point. So we just label them A and what? And B. So let's find those critical points here. So we are going to be solving the x coordinates of A. So the x coordinate of A, we are taking this graph of y is equals to minus open brackets x minus 5 close brackets, the reflected one from this one here, then intersected with the graph of y is equals to minus open brackets 2x minus 3 here. so they are intersecting at this point. So this is going to give us x is equals to minus 6 here. That's the point that we need here. X is equals to minus 6. Alright, then we go for the x coordinates of B here. So the x coordinate of B, you can see we are going to be taking this graph here of y is equals to 2x minus 3, and the graph of negative open brackets x minus 5 here at this point here. That's the intersection. Alright, so we are taking that one. So if you solve, we are going to have 3x is equals to 6, so x is equals to 2. That's your critical points. Alright, so now our region that we want, we need a region where the graph of modulus of 2x minus 3 is below the graph of y is equals to modulus of x minus 5, because it's less than here. The graph of modulus of 2x minus 3 is now less than the graph of modulus of x minus 5. So you can see here, this is the region here. The graph of modulus of 2x minus 3, this is the blue one here, you can see is now below the graph of modulus of x minus 5. X minus 5 from this point to this point is now below here. So we need it from point A to point what? Point B. So what it actually means here, our solution is going to be x is going to be minus 6 less than x less than what? Less than 2. That will be our solution, since this will be the region where the graph will be less than the graph of modulus of 2x minus 3 will be less than the graph of modulus of x minus 5 here. Alright, so thank you for watching the video. See you in the next lesson. Alright, so here we have some practice questions that we can practice here. Alright, so we have 6 questions that we can practice, and the solutions are here. Alright, so thank you for watching the video. See you in the next lessons.